During the previous lesson, we might have realized that prompting the entire chat log is the least efficient way of remembering a conversation. As the conversation grows, the chat model needs more time to respond. Not only that, it also uses up more and more prompt tokens. The easiest way to remedy this is by enforcing a cap on the number of interactions you allow the chatbot to remember. Once that cap is reached, the message that come earliest in the conversation are dropped from the memory. Let's impose a cap. For that, we need to set up configure parameter called k. Before this, I'll have to run the code to check my LangChain model. So I'm going to use pip show LangChain. Let's run this cell to see the metadata regarding my LangChain. Here you can see all the relevant values are showing at my screen. Now I'm going to import %load underscore extension of my dot environment, and this dot environment will be imported here. Now you can see I can access my API keys also. Now I'm going to import some conversation memories related file. If you remember that we have already imported so many libraries here. We have already worked on chat OpenAI, system message, prompt template, human message placeholder for dynamic variable, LLM chain for my LLM transformer, then chat message history, and the new one I'm going to import it here is conversation buffer window memory. I'm going to import this memory for further classification for proper channel to keep recording every there. So this is a new class, and also importing my verbose so that I'm going to keep it true. I can set it true because I want to see all the conversation at the screen. I'm going to create chat OpenAI for my model name, for my certain seed, and temperature is this relevant. So let's run the above cell so that I can import relevant libraries. Now I can run this long chain and chat OpenAI for my maximum token is 100. You can increase this token size. Now I'm going to assign this system message to my content and human message prompt for this certain question. This would be input variable, and message log would be my input variable, and will assign this order: first system, then history, then template. Let's run this cell. Now allow me to add chat history message in my portal. So if you will check, background info is currently showing nothing. You can check this information. But once I'll add these two messages, it will add these two user messages. First is user message, second is AI message. So let's impose a cap as we were defining initially. I'm going to increase this conversation buffer window memory. This will be imported. This would be configured by this buffered parameter. So this need to configure a parameter called k. We can include for k is equal to 3, k is equal to 4, or other things. So it also uses up more and more prompt tokens, the easiest way to remedy. This is why enforcing a cap on the number of intersection you allow the chatbot to remember. Once that cap is reached, the message that comes earlier in the conversation are dropped from the memory. Let's run this cell so that we can import these variables in our chat memory. So I'm going to initialize this buffer memory function, and using this buffer memory I'm going to initialize my LLM chain. So this would be first taking my LLM chat that is defined here in this chat OpenAI. Then I am using my prompt, which is defining here. You can see chat template is there. This is defining prompt template. Then I am using my memory. So chat memory is defining in the last section. I am going to create this LLM chain. Let's respond this chain which is having some question. So I'm going to define some question here. So let's ask some question. Can you give me interesting fact I probably didn't know about? So it's giving this prompt formatting. System is asking this question and you are really how to make entrance you don't know. Can you give interesting? So this is a human question. And you can see because I have turned on my verbose as true, this is showing, this is the reason it's showing all the relevant prompting sequence. Let's ask another question. What kind of relevant question I can ask? Can you elaborate a bit more on this fact? So what is the fact here? That's the question mark. This fact is talking about previous question, and this fact is previous interesting factor. This is flamingo or the relevant consecutive question. And you can see this is showing 1, 2 questions are prominently showing at the screen. Now can I ask another question? Yes, I can ask another question one more time. And can you see it's still showing 2 responses here, not the previous questions. Can you see 2 AI messages are there? First system AI, first system AI. Not more than AI questions are displaying here. If I ask any other question, this would be logically this would be fourth question, and with this query, with this prompt, I'm invoking my method 4th time. But if you look at the output here, how many questions do I have? So this is first AI response, this is second AI response, that's it. Why? Because we have defined k is equal to 2 initially in my function. If you go up, you will find this is encapsulated with k is equal to 2 only. Can you see this is having k is equal to 2? If you increase this number, you can see more responses in this same fashion. Now let's ask some more questions here. So I'm going to increase my cap channel. Now I'm going to increase my value, my k value, which is 4 now, and let's run. I'm going to create my chain LLM again and going to ask the same question. Now go up and let's run their same question again and again. So I'm going to ask very first question. This would be the first question. Can you see 1, 2, 3, 4, 5? These 5 questions would be there. Now you can see this is displaying 5 relevant AI responses. 1, 2, 3, 4. So these are showing 5 responses there. Let's run another question. We have running the next question. Now you can see 1, 2, 3, 4 and 5 are 1 is system. So these are 1, 2, 3, 4, 5 questions are showing here. Now let's run another question. So here you can see this is again showing 1, 2, 3, 4. Why? Because if you have defined k is equal to 4. So system is responding with 4 prompt values. Let's start with 4th engineering again. Can you see 1, 2, 3, 4? 4 responses are now showing. If you increase this k value, you will have more buffer memory and previous values will be deleted one by one. If you will print this response, you can find the chat value will have certain value. So this would be the final conclusion based upon all your 4 previous questions. But if you have k is equal to 2, you will get only 2 previous memories only. But this will concluding and including all the 4 memories there, apart from with this respective variable and so on. Thank you.